Project 1.3, ACES Christmas Tree. This project has 4 circuits: the RC oscillator, the 4060 frequency divider counter, multiple strings of LEDs, and the RSGC ACES Christmas tree. The RC oscillator is the first circuit. This circuit consists of 9 parts: one 9-volt power source, 330k ohm fixed resistor, 47k ohm fixed resistor, 10k ohm fixed resistor, green 5mm LED, 1 microfarad capacitor, 12mm square PBNO, 4011 NAND logic gate, and a 4069 inverter logic gate. This circuit uses a combination of logic gates, resistors, capacitors, and an LED to generate an oscillating signal. The 4069 inverter is a hex inverter integrated circuit that produces an output that is not of its input, while the 4011 NAND gate is a quad NAND gate integrated circuit that generates a low output when only both of its inputs are high. The feedback loop is formed by connecting the output of one inverter from the 4069 to its input, creating self-reinforcing oscillations. The output of the inverter is linked to one input of the NAND gate in the 4011, establishing a reciprocal influence that further contributes to the oscillatory behavior of the circuit. The resistor-capacitor network introduces a time delay. The LED is driven by the output of the NAND gate, resulting in an oscillating signal. The reset button, connected to the first pin of the 4069, allows manual control over the oscillations. Binary numbers are fundamental in the operation of the internal counters and dividers within these chips, influencing the frequency of oscillations and resulting in the behavior of the circuit. The 4060 frequency divider counter is the second circuit. This circuit consists of 7 parts: one 9-volt power source, 330k ohm fixed resistor, 47k ohm fixed resistor, 10k ohm fixed resistor, 3 470 ohm fixed resistors, 1 RGB 5mm LED, single pole double throw slide switch, 1 microfarad capacitor, and a 4060 frequency divider chip. This circuit uses the 4060's internal frequency division capabilities to create an oscillator. The 4060 IC is a 14-stage binary ripple counter and oscillator where an external capacitor and resistor determines the oscillation frequency, and its cascaded stages divide the internal clock signal to reduce various output frequencies. The external analog components shape the timing characteristics of the oscillator. By connecting an RGB LED to specific output pins of the 4060 and using resistors on its anode leads, the circuit produces a counting effect with varied color sequences, exploring the different frequencies generated by the internal division stages of the 4060. Multiple strings of LEDs is the third circuit. This circuit consists of 10 parts: one 9-volt power source, 330k ohm fixed resistor, 47k ohm fixed resistor, 7 red 5mm LEDs, 7 yellow 5mm LEDs, 3 green 5mm LEDs, 4 blue 5mm LEDs, 1 microfarad capacitor, a 4060 frequency divider. This circuit uses the 4060's internal binary ripple counter and oscillator to create an oscillating signal. By connecting the 4060 to separate strings of LEDs, each series of LEDs counts in response to the internal frequency division stages of the 4060 as the binary counter progresses through its states. The final build with a PCB is the RSGC ACES Christmas tree. This circuit consists of 9 parts: one 9-volt power source, ACES Christmas tree PCB, 5.5mm kinked power jack, slow fade flashing RGB LED, 16-pin kinked IC socket, 4060 frequency divider, 2 conical compression springs, 1 3D printed star, and a 3D printed stand. This circuit is similar to the multiple LED circuit and is shaped like a Christmas tree, implementing a PCB. The PCB simplifies the soldering process with 32 built-in LEDs, 1 capacitor, and 2 resistors. This project demonstrates the cooperation of digital chip components, resistors, and capacitors, particularly highlighting the versatile 4060 with its internal oscillator. Through the exploration of logic gates, truth tables, and binary numbers, putting these parts together in an attractive design demonstrates how the device can create oscillating lights, and it can be useful for things like timers and controlling time intervals.